In today's lecture, we will discuss how a neutral object can be charged by three different methods called charging by conduction, charging by induction, and charging by friction. We know that to electrify a neutral body, we need to add or remove the charges. For example, a body will become positively charged when it loses some electrons, and it will become negatively charged when it gains some electrons. Thus, we can say that a positively charged body contains deficit of electrons and a negatively charged body contains excess of electrons. So, charging means gaining or losing of electrons. There are three ways a body can be charged: charging by friction, charging by conduction, and charging by induction. The first method is called charging by friction. This method involves rubbing of two uncharged objects together, resulting electrons moving from one object to another. This method is very useful for charging insulators. For example, when a glass rod is rubbed with silk, glass rod acquires a positive charge and silk acquires a negative charge. Similarly, when a balloon is rubbed on a wool sweater, balloon acquires a negative charge and wool acquires a positive charge. In both these cases, the amount of electrons gained and lost is equal to each other. For example, if glass rod acquires plus 5 charge, then silk cloth will attain minus 5 charges. The amount of electrons gained by the silk is equal to the amount of electrons lost by the glass rod. So we can say that the charges of the system are conserved. The second method is charging by conduction, and this method involves touching a charged object to a conductive material so that some of the charges will be transferred between the object and the conductor. This process is also called charging by contact because it involves contact. And this method is very useful for charging metals and other conductors. Now, let's see how do we charge a neutral object using a negatively charged object through charging by conduction method. Consider a metal sphere mounted on an insulating stand. Here, the metal sphere is electrically neutral, which means it has an equal number of positive and negative charges. If anything changes this balance, then it gets charged. Suppose if a negatively charged rod touches the metallic sphere, some of the charges are passes from the rod to the sphere and metal sphere acquires a negative charge. Since this is a conductor and the charges cannot stay at one place, we have discussed in the last lecture that where does the charges on a conductor located? It's a very important point to remember that for a conductor, charges are located at the surface. It cannot stay at one place because charges are free to move inside a conductor. So it is evenly distributed over the entire surface of the conductor. And the distribution of charge is due to electron movement. Do you ever think that how is this happening? Here, the sphere gets an excess negative charge, which means it gets excess electrons. We know like charges always repel each other. So there is a repulsive effect within the conductor. In order to reduce this overall repulsive effect, the excess electrons are migrated throughout the entire surface of the conductor. This is the reason why we say that excess charges are always distributed itself throughout the surface of the conductor. This is a very important point you should remember in the case of a conductor. So here, when you touch the metallic sphere with a negatively charged rod, charges transfer to the sphere. As a result, the metal sphere becomes negatively charged and these charges are distributed across the surface of the sphere. These charges cannot move outside because the sphere is mounted on an insulating stand. And we know that insulators cannot conduct charges. So these charges only stay on the surface until there is a source to transfer this charge. Also, after the conduction process, the rod has less negative charge because it lost some of its charges. But the overall charges before and after the conduction process are same, which means the charges are conserved here. Now, in a similar way, we can charge a metal sphere positively. When you touches the metallic sphere with a positively charged rod, the metal sphere acquires a positive charge. Please note here that it is not the positive charge transferred to the sphere from the rod. Positive charges means it is the charge of proton, and we know that protons cannot move. Only electrons can move. If the positive charges cannot move, then how does the sphere get the positive charge? The answer is, an object becomes positive charge when electrons removed from it. So, from an electron perspective, we can say that a positively charged object contains deficit of electrons. So, when you touch the positive rod on a neutral sphere, the positive charges on the rod attracts the electrons from the sphere. Thus, the electrons migrate to the rod until the positive charge on the rod metal sphere system becomes redistributed. When electrons are lost to the rod, there is a shortage of electrons on the sphere. As a result, the metal sphere becomes positive charge. Since this is a conductor and the charges are uniformly distributed over the entire surface of the sphere. So this is the actual process happening here. This rod still have a positive charge, but it has now a less positive charge than it had before the charging process, because only a certain amount of charges is transferred between the rod and the sphere, and the charges are conserved before and after the conduction process. So this is the way we can charge a neutral object using conduction method. The next method is charging by induction. In charging by friction and charging by conduction methods, electrons are transferred when objects touch one another. But in induction process, we are charging an object without touching the object to any other charged object. In lecture 2, we have discussed how an electroscope can be charged without touching it with a charged object. Now, let's see how can we charge a metal sphere positively without touching it with a charged object. Consider a metallic sphere mounted on an insulated stand. Here, the sphere is electrically neutral, which means it has an equal number of positive and negative charges. Now, when we brought a negatively charged rod close to the metallic sphere, the free electrons in the sphere move away from the charged rod, because this is a negative rod and the electrons are also negative. So there is a repulsive force experienced here. Due to this repulsion, electrons move away from the charged object and starts to accumulate at the farther end. This separation of positive and negative charges in a neutral object is what we call polarization of charges. We will discuss this topic in more detail in the coming lectures. So here, the presence of a charged object near a neutral conductor induced, or we can say, it forced the electrons within the conductor to move. And this charge distribution stops when the net force on the free electrons inside the metal is zero. These charges cannot move outside because the sphere is mounted on an insulated stand, and outside the sphere the medium is air, and air is an insulator, so it does not conduct charges. So this charges remains on the surface of the metallic sphere. Now ground the sphere with the conducting wire. Then electrons flow to the ground. But this positive charges remains there because they are attracted by the negative charges on the rod. These charges are known as bound charges because they are attracted by an external charge. So they cannot move. And these negative charges are called free charges because they are not influenced by any other charges and they are free to move. If we are given a conducting path here, then these charges will flow. So these are the bound charges and free charges of a conductor. So here, when you ground the sphere, the free charges move to the ground and the bound charges are attracted by the external charge and stay there. The next step is disconnect the grounding, and we can see that the positive charges are still remains at the near end. Now, when we remove the charged rod, these charges spread uniformly over the entire conducting sphere, and we get a positively charged sphere. Initially, the sphere was neutral. Now it gets charged. Here, the metal gets a charge which is opposite to the charge of the rod. Also, there is no transfer of charges takes place between the rod and the sphere. So this is the way we can charge a metal sphere positively using induction process. Now let's see how do we charge a metal sphere negatively using the same procedure. Consider a neutral metal sphere mounted on an insulated stand. Here we bring a positively charged rod close to the metallic sphere. When a positive rod brought near the sphere, the electrons move towards the positive rod due to attraction and accumulated at the near end. As a result, this end contains excess of electrons and becomes negatively charged, and this end has a deficit of electrons and becomes positively charged. Now, when you ground the sphere, the electrons enters from the earth to the sphere and neutralize this positive charge. The next step is remove the grounding, and we can see the negative charges are still remains there because they are the bound charges and they are attracted by the positive charges on the rod. When you remove the charged rod, the negative charges distribute uniformly over the entire surface of the sphere. Thus, we get a negatively charged metal sphere. Here also, the metal sphere acquires a charge which is opposite to the charged object, and there is no transfer of charges takes place between the rod and the conductor. So this is the induction process, and through this process we can produce a negatively charged conductor and a positively charged conductor. In today's lecture, we have discussed different methods for charging a body. In the next lecture, we will discuss about electric charges and their properties.